Hello, everyone. My name is Harita Reddy, and my project is about governed conversational analytics assistant, in this case, omnichannel retail. I chose this project because my background is in data platforms and analytics, and I have seen how difficult enterprise analytics becomes when large volumes of data are spread across different systems, formats, and business owners. This assistant turns natural language business question into an evidence-based answer with the right business owner identified for the follow-up. It uses governed data, read-only tools, and a multi-agent investigation workflow instead of relying on prompt-only LLM. The goal is to show how Agentic AI can support faster and safer enterprise decision making. The LLM helps communicate the final answer, but the governed tools control the definitions, numbers, evidence, safety checks, and recommended actions. To understand why this matters, let's understand what happens in large-scale retail enterprise analytics. Retail leaders ask simple questions like why conversion dropped or why e-commerce revenue does not match with finance, but the answer usually lives across many different systems and teams. Finding that answer can take hours or days because teams have to pull extracts, reconcile definitions, and debate root cause. Today, all of this becomes super expensive for enterprises. A prompt-only LLM is not enough here because it can use the wrong definition, miss data freshness, or state a cause it cannot prove. And these decisions affect revenue, inventory, operations, and hence finally the customer experience. My goal was to prove a safer agentic analytics pattern for this problem. Again, my technical goal was to prove how an LLM, vector database, knowledge graph, and read-only analytic tools can work together for enterprise decision support. The system takes a natural language questions and turns it into evidence-based answer with agent-assisted, graph-guided owner routing in seconds. That is the leap I wanted to show. Conversational analytics moving from simple Q&A to governed investigation workflow. The assistant can investigate on its own by planning, retrieving, validating, querying, reasoning, and synthesizing, but it does not take business action on its own. It stays local with free read-only and synthetic data with no connection to production systems because it's a POC, and also it's an analytics pattern. This leads to the first design principle on why autonomy has to be bounded. The system is autonomous in the right sense for this project. It classifies the question, retrieves governed context, validates the definitions, chooses the graph-approved evidence paths, runs select-only DuckDB queries, scores branches, and then finally synthesizes that answer. But any write-style request is refused and converted into a recommendation for the responsible owner. Low confidence, tail sources, unresolved ties, degraded agents, and executive briefings escalate for the review. The key design choice is to separate investigation autonomy from business action autonomy. The agent can investigate, but people approve actions. To make that trustworthy, the system needed a component-level trust contract. This app has 7 specialized domain analyst agents: marketing, merchandising, fulfillment, digital analytics, customer service, finance, vendor, or category. They all run in parallel for domain investigation. There are also 6 supporting roles: orchestrator, semantic RAG, graph reasoning, citric evaluator, synthesizer, executive summary, and auditor guardrails. These are implemented as LangGraph workflow roles, not uncontrolled agents talking to each other. Each role receives a scope task through typed shared state and returns structured outputs. This makes the system testable, reliable, and auditable. Now let's look at what React means in this implementation. In this app, React is not a free-form loop where the LLM decides its own next tool call. I encoded the reasoning act observe loop as explicit LangGraph nodes over typed share state. Each node either calls one governed tool or makes a gate decision, then writes the observation and audit event back to a state. For direct analytics questions, the app takes a short path: classify, retrieve, validate, run the SQL, and then finally give the answer. For complex investigations, the loop uses dispatch, citric, and evidence gate, while the LLM only drafts the final wording after the governed numbers are already set. Once the React loop is structured, the deeper reasoning can be bounded instead of leaving it open-ended. Complex investigations activate tree of thought only when multiple driver paths compete or evidence conflict. The tree of thought search is bounded with beam width 2, depth 2, and a query budget of 8. The citric scores each branch on a 0 to 14 rubric and prunes weak or ungoverned paths. In the seeded scenario, the ungoverned price increase hypothesis is pruned. The final signal is not overstated, and genuine ties escalate instead of forcing a false root cause. This keeps the system analytical without letting it wander. The evaluation shows whether those design choices actually work in the implementation app. The fixed seed evaluation passed really all checks, 16 out of 16 data validations, 43 safety checks, 69 unit and integration tests, and 0 UI exceptions, which correctly detect the 22.9% conversion drop, identify the 3 true drivers, pruning, unsupported hypothesis, and safety routing negative cases with full traceability. This proves governed behavior on synthetic benchmark. It does not claim production accuracy on live enterprise data. And finally, how this pattern really moves from local prototype to enterprise platform. The enterprise path is to move the local DB prototype to governed lakehouse warehouse or federated read-in-place model using certified silver or gold data products. The agent layer can stay mostly the same, while enterprise services add access controls, lineage freshness, data quality approvals, rollbacks, audit logs, kill switch, etc. The key takeaway is that governance and trust are the bottleneck. The LLM helps communicate the answer, but the real business value is governed, auditable, agentic investigation pattern that turns scattered data into faster, safer, owner-routed decisions. Finally, I want to show the GitHub VS Code demo path for the project. The README explains the problem architecture setup, usage, and demo flow. The app folder contains the Streamlit pages and user-facing tabs. The catalog folder holds the YAML source of truth for metrics, tables, drivers, and guardrails. The agent folder defines the 7 specialized analysts, agents, and their parallel dispatch. The skills folder contains the governed tools wrapper for catalog lookups, retrieval, graph reasoning, SQL validation, evidence scoring, tree of thought, audit, and LLM drafting. The workflows folder contains the LangGraph, state graph, and investigation notes. The evals and test folders contain the validation suite, safety checks, and unit and integration tests. The command Python toolspy gives the fastest path to set up and run the prototype locally. The main takeaway is that the system is fully inspectable in code and not just described in slides. So please take a look at the GitHub. So here's my app on the left side, and on the right, I have the PowerShell open. So again, Python tools.py is going to really install everything I need for this app to run. So I'm just going to hit that just to showcase really that it installs the Olama model, which is the 2.75B for my specs of RAM. Otherwise, it has a fallback, as you see on the left side here. So right now, it ran everything I needed it to run, passed some checks that are coded into the app. So I have the localhost set up on 8501 port. So I'm just going to reload this so the app actually works. So I do have a clear, very concrete executive summary business problem, which I already discussed in the PowerPoint. Detail architecture, the current reference architecture, along with supervisor orchestrated, which I demoed again in the PowerPoint, also detailed reference architecture for real-world implementation. So in the interest of time, I'm just not going to skip that for now. Data catalog, again, showcases metrics, tables, drivers, the lineage, where network knowledge graph was used to build this. Run analysis is the main tool that I was shooting to really get to demo here. So again, you see, we talked about the Olama Quen 2.7B fallback and what it's running currently. So I see the daemon reachable. So that's a good sign. So my app should work now. Again, I've coded in various really questions and edge cases to test this. By my demo question, again, the main retail question of why did conversion drop yesterday, right, compared to the 7-day average. Before I hit that, just the TOT beam width and TOT depth and the top K are also coded, so I can play with those parameters and see if it makes a difference in the response of the investigation. So we'll demo that as well. Also coded in what happens if one of the assistant that's most needed actually fails in the investigation. So we'll showcase that too. So let's run the run investigation to see what the response would be for this demo question here. Again, you can see the live running trace as it goes through. It really parallelly goes through those 7 domain analysts and then really picks the likely driver, right? That's what you're saying. So for this demo question, again, it shows the needed information for the business user here on why the 23% compared to yesterday, right? And the 3.6% drop. So I'm not going to get into the business details, but you can see that it really gives the executive summary to really what to act on now, what to investigate, and what to monitor, and picking these two as a likely driver, merchandising and fulfillment operations, right? So and the next here really showcases how those 7 agents parallelly run, the query times for those. What was the evidence based on? Again, you can see the details of what were coded in for drivers and what was pruned in the process of picking the answer for this. Really, the trust details, and where and whether it used a sentence transformer or a multi-agent path is what really comes out here. The TOT trace here and what was true is showcased here. Technical audit, again, details of really what goes across the domain investigation when all the analysts were engaged in the process. So it's very detailed, just so I can understand, not just to showcase, because which was important to me to ensure the project really works in real life, right? So let's go back here, which is a demo question. And again, what I wanted to showcase is what happens. I think one of the feedbacks was what happens if 2 of them have the same rubric score, right? After the investigation was done. So this actually is yesterday's conversion drop. Merchandising blames the electronic stockout. Fulfillment blames the West delivery delays, which actually is a real driver. What do we fix first? So, what you notice here is, again, the intention is to see, what were like really possible contributors and what was pruned. But again, what the main thing is a tiebreaker, right? So here's it clearly says the fulfillment constraint versus inventory availability both had a tiebreak, and hence the investigation really escalates to a business owner. So that's what you're seeing here. So that's that, and obviously we really wanted to show stale data. So that question really translates to stale data. The expectation is to see when it runs that it really tells the user that you're taking a decision on stale data, right? So it's working as designed. What I'll quickly jump into, and I did code other edge cases, but in the interest of time, I do want to talk about what happens if I just take the beam width to just 1 node, right? So, and for the same, I think the conversion demo question, I think, is what's important to showcase here. So if I do just 1 node width for the TOT trace, what happens, right? So it clearly just looks at just the merchandising. It doesn't really pick any other. So that's what it's working as designed, because it only hits 1 node. The next would be for the same demo question, I'll put things back and then I'll fail the merchandising inventory related analysts and see what happens, because it's one of the dependent analysts and the most likely contributor, rather. So let's see what happens. The expectation is it should skip the merchandising analyst, still point the user for that, or point out to the user that it failed, and then still give the response. So clearly you can see that it alerts the user that the merchandising analyst has failed, and it's really taking a decision on partial investigation. So it still gives users some business-related response and the likely drivers working as designed, so users can make decisions while they recover the agent. So that's all. I'll actually stop here, and then thank you for listening.